In this video, we're going to discuss the present value of money. In actuarial science, we often come across problems where there's an obligation to pay a defined amount of money at some future point in time. This could be, for example, a pension payment, a life insurance payout, etc. Our job is to calculate the investment needed today so that this investment plus interest is sufficient to cover the obligation. Let's use a simple example to illustrate the mathematics. Suppose you need to make a payment of $1,000 in 5 years' time. We need to solve for x, also known as the present value of our obligation, $1,000 in this specific scenario, given a compound interest rate of, say, 10% per annum or per year. From our knowledge of future values, we know that the investment x will be worth x multiplied by 1 plus the interest rate, which is 1.1 to the power 5 in 5 years' time. We set this equal to our obligation of $1,000 and then solve for the unknown. If this doesn't ring a bell, I would recommend that you watch the video on future values again. I have included a link below for ease of reference. Now to solve for x, we divide by 1.1 to the power 5 on either side. So to solve for x, we need a quick recap of one of the laws of exponents. When working with a fraction, for example, 1 over x to the power 5, we can move x to the power 5 to the top of the line by simply changing the sign of the exponent. In other words, we can say this is x to the power minus 5 over 1, and any number over 1 is just the number itself. So x to the power minus 5. By using this rule, we can rewrite our equation as x is equal to 1,000 multiplied by 1.1 to the power negative 5. The formula is very similar to our formula for calculating future values. As a reminder, the future value is equal to the present value times 1 plus I to the power positive n. So the only difference between the formula for future values and present values is the sign of the exponent. When moving money backwards through time, we use a negative exponent. On the contrary, when we move money forward in time, in other words, calculate future values, we use a positive exponent. So in general, we can write the present value as the future value times 1 plus I, which is the interest rate, to the negative n, where P represents the present value, F is equal to the future value, I is the interest rate compounded in this case per year, and n is the number of years. Because we use the formula so frequently, we have a shorthand way of writing this in actuarial notation. Before I can show you how this works, we need a quick refresher on another aspect of the laws of exponents. What is x squared raised to the power 3? Now in this example, we need to multiply the two exponents, and that is equal to x to the power 6. Now to see why this works, remember that when we have a power, it is simply an instruction to multiply a number by itself x times. So in this scenario, we are saying take x squared and multiply by itself 3 times. X squared is simply an instruction to multiply x by itself. So we can further simplify this equation as such. Now, if you count the number of x variables in this bottom formula, you will see that we have 6 of them. Hence, the answer x to the power 6. So to write this formula in actuarial notation, we need to define a new variable. This variable is called the discount factor in actuarial notation. We use the number v and we define this variable as 1 plus I to the power minus 1. Now, using the laws of exponents, we can see that we can rewrite the equation for present value as f times 1 plus I to the negative 1 to the power n. You can see that if we multiply the inner exponent by the outer exponent, we simply obtain minus n as a result. And that is exactly the original equation that we had. Now the insides of the square brackets equals the definition for v. So we can rewrite this as present value equals future value, keep the square brackets to the power n, and substitute this value for v. Now to get rid of the square brackets is fairly easy. All we need to remember is that this v, although there's no exponent written here, it is actually v to the power 1. Now from the law of exponent, we know that we can simply multiply 1 by n to obtain the final value, and that is simply f times v to the power n. Memorize this formula since you'll be using it a lot for this exam. Now that is it on present values. I hope that you've enjoyed this video. If you have any comments or suggestions, please drop me a note. Thank you for watching.